Are electronic toys or devices interesting to you? Do remote control machines or robots catch your eye? These interests can be the foundation for a suitable career that provides satisfaction where your work feels less like a job and more like a continuation of your hobbies. At Cummins, we use both robots and cobots in various ways where high repetition and safety issues are present for our workers, such as loading and unloading block castings and other parts in and out of our machines. They reduce the risk of injury so that we can protect our workforce and are quickly becoming a part of today's industrial manufacturing, which is so important in providing products that we all rely on. Let's explore some of the examples of job positions that support and provide interaction with the latest technology by way of collaborative robots, otherwise known as cobots.
Hi everyone, my name is Nick Dunn. I'm a manufacturing engineer here at the Jamestown engine plant. My focus is primarily on the 15-liter assembly line. I'm here to talk to you today about a few of our new collaborative robot cells. A little background on myself. I'm a mechanical engineer. I've been with Cummins for just over 4 years now. I hold a bachelor's degree in mechanical engineering from Alfred University. What you see behind me is our new oil pan cobot cell. This is a cell built by an integrator out of Pittsburgh, Pennsylvania. They are designed to torque all the bolts on our 15-liter oil pan. So what you see is two cobots designed to do half of the oil pan each in order to meet our cycle time. The gains of this cell include some quality gains. So we no longer have to worry about the opportunity of missing a bolt when we torque all the oil pans. As well as ergonomics, it no longer requires two operators to be standing here torquing oil pans. It's a very repetitive job, and now our cobots take care of that for us.
My name's Angela. I'm cell leader here, which means I oversee all the making sure we have all our parts and communicate with the other areas in the plant when we need something. I've been with JEP about 7 years. Prior to getting the cobots, we used two operators to torque the oil pan. Now that we have the cobots, we don't need those two operators and can utilize our time elsewhere in the cell.
Hello, my name's Matthew Welch. I am an electrician here at JEP. I've gone through almost an associate's degree worth of college work and 5 years of on-the-job training to get to be an industrial electrician here. My role in the robots, I've helped install all of the cells on the assembly side of the plant, and I continue to help maintain, troubleshoot, and improve through programming or any other means all of the cells over here. It's a great field, and it's really rewarding to see your work go into motion like this and see something you've built.
The cobot cell that you see behind me is known as our fracture split rod cell. This cobot is designed to pick and place connecting rods from the containers they are shipped in into a machine that processes the rods for assembly. The machine is set up to run a part every 15 seconds. The robot is designed to keep up with that. What you see behind me is two containers of parts. The cobot has a camera system located up above that will take pictures of each box to tell the cobot how many rods are left in each container. Then it will pick and place those into the machine until the box is empty, switch to the second box, and then run those. Each part is roughly 14 pounds, so this cell used to be manned by a single operator who would rotate out every hour. So there's obvious ergonomic and quality gains to this. A operator is no longer required to load every part every single time. And each part is handled by the robot, which eliminates the possibility of dropped parts or damage, things like that. So what you see is 12 rods per layer, 12 layers per box. So we go through several boxes at minimum every day. So you can see this was a very repetitive task for an operator to do throughout the day.
Hey everybody, my name's Calvin. I've worked at Cummins for 17 years now, a lifelong resident of Jamestown. when I started here, there was no robots. We did everything by hand, you know, and it wasn't too bad at the time, I thought, until we started getting some robots to help us out. And I think they helped us out quite a bit, like this one here right behind me. You know, we used to have to open up every rod box and take every rod out manually, mark them, and place them in the machine. And now we have a pretty cool machine that does it for us, picks them all up. They're kind of heavy. You know, 14 pounds, it doesn't sound like much, but when you're lifting hundreds of them a day, you know, the machines definitely help out. To get this job that I have, you know, I went to JCC, and also Cummins provided quite a bit of training for me. You know, it's helped me out a lot, and I don't know, I kind of think it's a pretty cool place to work. But, yep, I hope you guys enjoy the video and have fun on whatever you do. Thank you.
Sharing with you another one of our robot cells. This is known as our piston cooling nozzle assembly cell. What you see behind me are 2 robots designed to pick and place and sub-assemble piston cooling nozzles for our 15-liter engine. You'll notice that these robots are a different style from our previous ones. These are built by a company called Universal, and these are designed to be a collaborative robot. Similar to our other cells, except for those cells use a traditional FANUC style traditional robot. So what you see is one robot picking the parts from pallets as they come in. They're placing them into an assembly fixture where a bolt is inserted. Then the part is picked up and set into a test fixture where it makes sure that air will pass through. And then they're put into a tray and assembled for the assembly line. This cell has been a huge advantage as far as ergonomics go. It eliminated the need to have an operator standing here doing this. It was a very repetitive, monotonous job where an operator would sub up hundreds of these per shift to meet assembly demand. So we've completely eliminated the need for an operator to do this. There's obvious ergonomic advantages to that. But from a quality aspect, now that the robots handle all of these, they're 100% inspected and tracked, so there's no possibility that a defective part could make it through.
Hi everybody, it's me again, Cobot Calvin. Yep, we have the most automation in my cell. Here's another cool piece of machinery. This one does everything for us as far as building the piston cooling nozzle, testing it, and then all we have to do is install it. Prior to this machine, we really had to scramble. It was hard to build the nozzle ourselves, and then we had to test it ourselves, and then install it into the engine. Now, it's so cool. We just turn around and the nozzles are right there waiting for us, like they're sequenced, so they line up right with the engine, you know, that's at our station. So, yeah, this one's one of my favorites. It helps us out quite a bit. You know, not to mention when we were building the nozzles ourselves, you know, we had to put in the cap screw, and by the end of the hour, you know, our wrist hurt a little bit. And this one just helps out quite a bit. I like this one a lot.
RX2 347 96B.
Bringing you the last of our collaborative robot cells. The cell you see behind me is called our liner spray oiler. So this robot is designed specifically to spray oil inside of the cylinder bores of the engine before pistons are installed. You'll notice that this is a truly collaborative robot cell and that there is no guarding around it. There are floor scanners on the ground that will notify when an operator steps in the cell, when an engine is incoming or exiting the cell. So no guarding is required. So this robot only sprays oil in the liners. which was actually quite an ergonomic and cycle time advantage for us. Previously, there was an operator standing in the station, and the only work that they really did was they would check one thing with a gauge, they would put some bolts on the engine, and they would spray the oil. So oil is being accomplished by the cobot, obviously, and now the other work content has been moved. So this station has been completely freed up by adding in a collaborative robot. That operator in the cell is now able to be utilized elsewhere, resulting in a pretty big advantage for us. You'll notice this robot is wrapped in a red protective jacket. This is still a universal robotics robot, similar to the ones in the piston cooling nozzle cell. However, the jacket is placed on it to protect it from the oil that it is spraying. It does tend to get over pretty much everything in the areas.
Behind me is the liner oiler. Before this cobot, we would have to manually spray the liners, and it just seemed like, you know, we were breathing in a little bit of oil. So I think that this cobot is like, it's safer for us. All we had to do was oil the liners, and then that was pretty much it. So we were just over there not doing a whole lot. You know, where we could be busier somewhere else, that's where this one helped out.
Hi, Matthew Mancuso here. I had the privilege of leading some of these projects as the lead engineer and project manager for many of the cells that you got to view on this video. A little background, I'm a Jamestown native. I grew up here, Jamestown High School grad. Went to JCC after and then transferred out to UB where I got a master's in industrial engineering. And it's been a great privilege to work here. To give you an idea of the career path that I had, you have now seen some of the applications in which robots are being used to improve safety, ergonomics, and efficiency within our manufacturing process. The future will be shaped by the use of such equipment, and the need for the labor force to design, build, and maintain will increasingly evolve as well. And hearing from the different folks on this video, you can see there are different career paths available to gaining the skills and ability to work on such equipment. Please feel free to reach out to the many resources, including our plant, within the community to learn more about our options to such career paths. Over the next year, our plant has plans to increase our use of automation in general, as well as we strive to keep the facility more efficient and a safer place to work for our employees. We hope that you'll join us in helping this place grow and strive within our market and within the community at large. Thank you so much for allowing us to share our process with you, and we look forward to the future for each and every one of you.